Hello, and welcome to Tektronix. Today we're going to talk about how to set up an RS-232 Bus Decode. The RS-232 Decode is a fairly simple and easy setup. As you can see, we have a USB to RS-232 cable and attached are a couple of mini gender changers with a resistor used to loop the signal. Because RS-232 uses single-ended signaling, we will need a single-ended probe. I will be using a TPP-1000 and I can probe anywhere here along the resistor, and I can ground anywhere that's not the resistor. And now we can connect our devices and proceed with our setup and decode a live signal. So from a default setup, we will select Auto Set to bring our waveform on screen. We can also increase our record length to 1 million for some additional resolution. Now off screen I am using Python shell on my computer to perform a serial tester, and it's important to note that I'm going to be running my command line at 9600 baud. But before we run our command line, we want to take a single acquisition and then run our command. Now we can see we are going to need to adjust our horizontal scaling, and we will do so until we can see our entire waveform. And now we can see we have a clear representation of our live signal. Select bus B1, and we'll just go ahead and move this below our waveform. And select our bus type, which will be RS-232. Now we can define our inputs. Our transmitted signal input is our source, which will remain channel 1. Our received signal input, which we do not have, will remain off. We can also choose our polarity. Because we are decoding RS-232 transmitted signals, we select polarity normal, in which the high equals 0. Polarity inverted, in which the high equals 1, is used for RS-422, RS-485, and UART signals. Select thresholds, and we want our transmitted signal threshold to fall somewhere around the center of the signal. Select configure, and we want to make sure that our bitrate is set to 9600 bits per second to match our signal, which it already is. You can see if I change the bitrate that our scope decodes at a bit speed different than our signal, in which we may see decoding errors occur. We also want to make sure that we are using 8 data bits. Because our characters are comprised of 8 bits, using 9 bits or 7 bits would result in decoding error. The data bits are transmitted in least significant to most significant bit order, with the optional parity bit following. If not used, as in our case, the bit is ignored. If used, however, the polarity must be programmed and provides simple error detection by indicating whether there are an odd or even number of ones in the data word. We can choose whether we want our packets on or off, as well as the end of our packet. As always, we can edit our labels. We can edit our bus display to display bus or bus and waveforms. We also have a few different options for our data values: hex, binary, and ASCII. Selecting ASCII, we can see our command line, which reads, "How to set up RS-232 Bus Decode." We also have our event table. If we turn that on, we can look at specific data values throughout the waveform. And if we have a flash drive, we can save our event table to a file to be used in Excel or MATLAB, etc. Now if we go into our trigger menu, we can also trigger on various bus conditions. And you can see they're all a little different, some allowing us to trigger on start bits, ends of packets, specific data values, etc. Thank you for watching our video. If you'd like to learn more information about our products, please visit www.tektronix.com/support.